I am doing the extra credit question, chapter 17, number 55. And it says an electric car is designed to run off a bank of 12-volt batteries with a total energy storage of 2 joules times 10 to the 7, no, 2 times 10 to the 7 joules. And for A, it asks that when the motor has 8 kilowatts, what is the current delivered to the motor? And B is if the electric motor draws 8 kilowatts and it's moving at a steady speed of 20 meters per second, how far will the car travel before it is out of juice? And so for A, first we'll find our givens. We're given that the car has 12 volts and it has a energy storage of 2 joules, 2 times 10 to the 7 joules. And so A, we're first going to convert 8 kilowatts to 8,000 watts, and we're looking for the current. So we're going to use the equation P equals IV. And P equals IV is power is equal to the current times velocity. And so once we have that, we're going to plug in our numbers. We're going to first change it so that we look for the current, and then plug in our numbers. And the answer to that will be 666.67 amps. That one is pretty simple. And then for B, it asks, how far will the car travel before it is out of juice? And for that one, we're going to use the equation velocity is equal to distance over time, change it so we look for distance, and plug in our numbers. But we only know time. No, we only know speed. We don't know the time. And so when I look back into the textbook, for example 17.7, they use the equation T is equal to the total energy over power. And they give us the total energy. So if you plug in the numbers, you should get 2,500 seconds. And if you plug the seconds into our equation earlier, we'll get 50,000 meters. And that's how you do number 55.